So now we're going to talk about some of the operations that you can do to lists. We've been talking about their internal structure, but now we're going to start working with them. So the first thing that we see here is that we can add them together. And it's just like concatenating strings. We concatenate lists together. It pretty much works the same way. Adding A and B to make C does not hurt either A or B. Slicing operator, again, think of strings, think of slicing, think of beginning position, up to but not including. So sub 1 is that position right there, up to but not including sub 3, which is 4112. So that's what we get there. Just like with lists, you can omit the first one, so that's up to but not including 4, which is this one right here. So this is the, 0, 1, 2, 3, 4. You'll mentally have to count that. Up to but not including 4, that's that one. 3 to the end, so 0, 1, 2, 3, that's 3 to the end. So that's 374 and 15. And then, just like with strings, you can have the beginning and the end. So it's very much like strings. Slicing of lists is like slicing of strings, except that the list is slicing entire cells within the string. Just like in strings, we have lots of library methods. There are lots of methods in the list object. Append, which adds a thing to the end of the list. Count, which actually, len tells you how many things are in a list. Count tells you how many things that match a particular thing are in a list. Extend, index, insert, pop, remove. There's a whole bunch of things, and they're all very well documented in the Python documentation. So we'll use a couple of these things. There's a couple of ways to build a list from scratch. We're calling this is constructor, and so list is a predefined type. This is the type of list. So we say make a brand new list. So that's like it's the same as saying give me an empty list and then assign it into stuff. So that is a list with nothing in it. So the length of that is 0. And then we say, oh, let's append the string book, and then let's append the string 99, and we print it, and now we have a book with 2 items. And so you can sort of do this over and over and over and append things if you like. And you can keep on going. We can append the string cookie. And so at the end of cookie, you've got 3 things in there, book, 99, and cookie. So append is a method. Now, recall that strings are not mutable, so all these methods would return variables, but lists are mutable, and so appending actually changes this variable. So note that stuff is different from here to here because we appended it. And that's because lists are mutable, but not strings. And so they kind of function a little differently. And just when you learn strings and you learn that the return value, so for example, you don't want to do something like x equals x dot append, because the return value that you get back here, the residual return value, actually messes x up. So you do not want to do that. You just say, x dot append, and that works a lot better. In, again, one of my favorite Python operators is in. In strings, you were asking if a character or substring was in another string. Here, now you're looking at the members of a list, and you're saying, is 9 somewhere in the list? Yes, it is. Is 15 somewhere in the list? No, it is not. And then not in is also an operator. It's the opposite of in. So is 20 not in the list? And the answer is 20 is not in the list, so we get back true. That's just a question that you can ask in any old if statement that you want. Lists maintain order. The order that you put things in is the order that you get them out. So append, 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 whatever you've appended, it comes out in exactly the same order. Lists maintain that. They're kind of dense and compacted, and you can only add to the end. Although you can say, push all those ones down and put something in the middle using insert if you like. But it also means then we can sort them. And so, here we have 3 things, Joseph, Glenn, and Sally, and we say, hey, friends, sort yourself. This is kind of more object-oriented. We call the sort methods within the friends object. And then now it has been changed, right? So it actually changes it, and so it's now in alphabetical order, Glenn, Joseph, and Sally. And friend sub 1 is the new sub 1, not, and so this actually changes it because lists are mutable. We have lots of functions. We've already played with len and talked about len, how many things are in the list. We can say what's the largest number of a list, what's the smallest number of a list, add them all up. What's the sum of this list? Sum of the list is 154, and you can calculate the average by the sum. Now, some of you who will go back to chapter 5 and say like, well, why did you give us all those for loops to do the same thing instead of just telling us this function? So the answer is, well, there are reasons for knowing how to construct those for loops, and they were good, easy to understand for loops. If you have a list and it's a list of numbers, these are far better than constructing a for loop. So all those examples from that earlier chapter, they're not the way you would do that particular problem, but sometimes you're reading through lines in a file and you have to do it a little bit differently. So here's a couple of loops that sort of demonstrate this notion of how you might use these functions to calculate an average versus how we calculated an average in the earlier chapter. Although I kind of redo this in a different way because now I'm pretending I'm reading from a file, but instead I'm going to read from input. I'm going to read the numbers ... until I get it done, and I'm going to calculate the average of those numbers. And so it's just a standard loop where we set total to 0 and count as 0. I'm going to make it a while loop. If I was reading a file, it'd be a for loop, but this is, I'm going to ask for some input, prompt it. If it's done, I'm going to break out of the loop. So that handles this case, so I can get out of the loop somehow. And then I calculate the floating point value of that input, and I add it to my running total, and I add my running count equals count plus 1, and then this runs, in this case 3 times, and then comes down here and computes the average and prints it out, and away we go. Okay, and so that's kind of the manually constructed loop with a manually constructed counter and a manually constructed sum, and away you go. Now, if I were to try to use max and min to accomplish the exact same thing, so what I would do then is I would accumulate these values in a list. So I'm using a data structure now rather than just logic. And so this is kind of an algorithm that's carefully constructed to produce the count and the sum when it's all said and done. Now what we're going to do is you can use a data structure to solve that same problem. And so we're saying, hey, let's make an empty list because we're going to accumulate some numbers. And then we have the same while loop, same 2 lines. We look for, actually, the same 3 lines. We get a value, we check to see if we're done, to get out, and we convert it to a float. But now, instead of doing the summing as we're doing here, we say, let's just remember that. We got this list, we're going to fill it up, we're going to put numbers in it. So we put a 3 in, we put a 9 in, we put a 5 in, and then put a 3 in, put a 9 in, put a 5 in. So we're not actually calculating any calculation. And then when we hit done, we come out, and we say, oh, let's calculate the average. Well, you've got these numbers in a list now. We have a list that looks like 3, 9, 5. That's what's in here. So we take the sum of that and then divide it by the len, and then we have the average. And this same program produces exactly the same output. Okay, so that both these things produce the same output. And you can decide for yourself which you think is more elegant. In general, there is one tiny difference between these two, and that is this one actually has to have all of the numbers in memory, and if before it can actually do the calculation. This only keeps one number in memory. And that probably doesn't matter if there's like 100,000 numbers or less, but if there's like 100 million numbers, this one doesn't use 100 million spaces in memory, and this one does use 100 million. So there are sizes of data that are large enough that it matters, the memory usage between these two things matter, because this requires 2 variables for any number. This one here requires 2 variables for any number of things we're going to do the average of, and this requires an extra bit of memory for every single number, so it scales based on the numbers. For the small stuff that you're doing, it hardly matters. And if you already somehow have these numbers in a list, this is a great way to do a sum. You wouldn't write the for loop to do the sum. If you've already got numbers in a list, then add them up with a sum or figure out the maximum using a function. That's just perfectly fine. So that's kind of manipulating lists and writing some interesting loops. And up next, we're going to play with connecting lists and strings together.